Right, gents, let's get stuck into these questions. So, what I'm going to do is I'm going to read through the question and circle the bits of information that I think are relevant to this question. So, Shaniqua really wants to beat her best friend Courtney in the upcoming School Athletics Carnival 2,000 metre race. Courtney runs the race with an average velocity of 5.5 metres per second. Calculate the minimum average velocity Shaniqua must run if she is to beat Courtney by at least 5 seconds. So you can see the first thing I've done here is I've said the time for Shaniqua must be equal to Courtney's time minus 5 seconds. So quite clearly the first thing I'm going to need to do is find the time that it takes Courtney to do this race. So I'm just going to rearrange the speed formula, and you can see I've got 2,000 over her time of 5.5 meters per second. And that gives me a total time of 361 seconds. So Shaniqua's time will need to be 361 minus 5, which gives us 356 seconds. So now, using the speed formula, I can find the minimum speed that Shaniqua must run this race in. And that will be 5.62 meters per second. Nice and simple. Okay, next one is two students in a PE class run a trial 100 meter race. Alice runs the race in 13 seconds and Jill runs the race in 15.5 seconds. The PE teacher wants to make another race in which both students will cross the finish line at approximately the same time. Calculate the head start needed for Jill in order to make this happen. Okay, so first thing we're going to do is find out the velocity at which Jill runs. When we do that, we can then find out how far she will run in the time that Alice ran the race. So she runs at a rate of 6.45 meters per second. So using the time that Alice ran the race, we're going to times that by her velocity to give us a distance of 83.9 meters. So in the time it took Alice to run 100 meters, Jill ran 83.9 meters. So now it should be pretty straightforward to figure out what that head start will be. And that gives us 16.13 meters. Quite an easy question if you get your head around it. A child being chased by an angry ibis is running in a straight line towards the safety of a nearby building at a speed of 3.25 meters per second. The building is a distance of d away from the child. The ibis is 12.6 meters behind the child, running at 4.85 meters per second. What is the maximum possible value for d if the child reaches the building safely? Okay, first thing I like to do with questions like this is draw a little diagram so I've got my head around what I'm doing here. So here's my diagram. So when the value d is at a maximum, it means that both the child and the ibis will reach the door at the same time, because if the child reached the door before the ibis, then that's a smaller value for d. If the d is any larger, the ibis is going to reach the child. So we say that the largest possible value is when they equal the same amount. So what I'm going to do is find an expression for time for both of their velocities and displacements, and then I can equate the two having the same time. So you can see I'm using the same equation here for both of them, where the distance of the child is d and her velocity is 3.25. For the ibis, it's the distance plus 12.6, but that should really be a d, not an s there. So now I'm equating the two, and what we're going to find is that that s is obviously the same as the d, so we can therefore make the question 4.85d equals 3.25d plus 40.95, and so now I just have one unknown variable, and that gives me a value of 25.6 meters. Alright, the last one, and this is my favorite question that I've ever written. A Jamaican sprinter runs the 100 meters in 9.89 seconds. He reaches his top speed 3.2 seconds after the race begins and maintains this for the rest of the race. Calculate his top speed. Now this is actually quite a simple question when you see the answer. Figuring out how to do it is probably the challenging part. So once again I'm going to do a diagram here, and I've got two displacements to work with here. The first displacement is how much distance he runs when he's accelerating to his top speed, and displacement 2 is how far he runs when he's running at his top speed at that constant rate. And I know that those two displacements add up to 100. So I can say S1 plus S2 equals 100 meters. So what I want to do is find expressions for S1 and S2. So S1 is that velocity we don't know, because in fact we know it's going to have we're going to have to get an average value for that velocity 1 because it's changing, and we know the time that it took him to do that. S2 will be that maximum velocity times T2. So what I want to do is find an expression now for V1, and as I said, it's going to be an average, so it's V2, because that's his top speed, plus his initial speed, divided by 2. It's just an average of those two values, his initial and final. His initial is 0, so V1 is actually just going to be V2 over 2. So now I can write S1 again as V2 over 2 times T1. So I'm going to substitute those two values that I have now, S1 and S2, back into that original formula up the top, so that I get V2 over 2 T1 plus V2 T2 equals 100. Now, we know the values for T1 and T2, so the only unknown variable in this equation now is that final velocity. So I'm just going to rearrange this, and I'll eventually come up with a value for V2. And there you go. His final velocity is 12.1 meters per second. Hope you found these solutions helpful. If you have any questions, do ask your teachers.